Applied Science and Technology Chemistry class. My name is NC Joshua, popularly known as Oracle. Today we'll be looking at electrochemistry and we'll be starting with electrolysis. Now, if you look at the word electrolysis, it's broken down into two. We have electro, which is gotten from the word which is mainly electric current, and we have lysis, which means to break down. So it means it is electric current that is breaking down the compound. Now you have a sketch of a DC source, that's a direct current source, supplying current into the 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 electrolyte, and the electrolyte is being dissociated. Now let's assume we have here, this is our electrolyte H2SO4. So it's been dissociated, and we have these as the electrodes through which current goes into the electrolyte. Now, look at electrolysis. We said electrolysis is the composition of a compound by the passage of a direct current. Take note, not an alternating current, but a direct current through it. Then what is an electrolyte? An electrolyte is an organic compound which conducts electric current in molten or aqueous state and solution, and decomposes in the process. So we are saying that a compound that can conduct electricity is called an electrolyte, and that compound can be either in an aqueous state or in a molten state. And when electric current is passed into that compound, it does something, dissociates the compound into ions, and these ions migrate towards the electrode. Now we have two kinds of electrode. If you see here, we have electrode. Okay, we have electrode here. Electrodes are poles connected to a DC source through which current passes through it. We have two types. We have the anode and the cathode. The anode is a positive electrode, while the cathode is the negative electrode. Now look at it over here. The anode, there are certain electrons that migrate towards the anode. So the negative electrons migrate towards the anode, while the positive electrons migrate towards the cathode. So if you look at it very well, we have this reaction occurring at the anode. This is minus 1 becoming 0, minus 1 to 0. This is oxidation, while this is plus 1 to 0, plus 1 to 0. This is reduction. So what are we trying to say? We're trying to say that in the anode, oxidation takes place, but at the cathode, reduction reaction takes place. Now, what about an electrolyte? We have types of electrolytes. We have a strong electrolyte, we have a weak electrolyte, and we have a non-electrolyte. Now, a good example of your strong electrolytes are strong acids, strong base, and practically salts are strong electrolytes. While our weak electrolyte, we have weak acids and weak bases. They are weak electrolytes. Then we have non-electrolytes. A good example of the non-electrolytes, we have the benzene, we have sulfur, we have kerosene, we have your glucose, your sugar table, or your that's your table sugar. Then we have urea. All of these are examples of non-electrolyte. So when we say it's non-electrolyte, means it cannot conduct electricity. When we say it is weak acid, it means the ions partially dissociate. Then when we say it's a strong electrolyte, we say the ions, they totally dissociate. Now, when these ions, when this electrolyte decomposes, when the electrolyte decomposes, the ions, not all of the ions can be able to migrate. For instance, where you have two positive ions or two negative ions, the both of them cannot migrate towards the pole. So one of them is preferred over the other. One of them, one of the positive is preferred, one of the negative is preferred. So you now have one of the ions migrating to the electrode, leaving the other in the solution, either a positive ion or a negative ion. So that leads us to what we call preferential discharge of ion. When an electrolyte dissociates, ionic theory, when it dissociates, you have the positive electrode moving towards the cathode, and you have the negative moving towards the anode. Now, which of these ions will be preferentially discharged? So we have three factors that aid preferential discharge of ions. What are these factors? Number one, we have position of the ion in the electrochemical series. Number two, we have concentration of the ion in the electrolyte. And number three, we have the nature of the electrode. Now we'll be doing some examples to show how ions are preferentially discharged over other ions. Thank you. Now, in order for us to be able to analyze preferential discharge of ion, we must have a glimpse of the series of electropositivity and the series of electronegativity. Now, if you watch what I have on the board, as it goes down, this shows increasing preference of discharge to the cathode. Now it means cations, these are cations, positive ions, they go towards the cathode, while negative ions, they go towards the anode. So this is increasing preference of discharge to anode. So it means as we go down, the ions below, they have more preference to be discharged over those above. So if I have a case of this ion against this ion will have more chance to be discharged over this. So ions below are preferentially discharged over those above. Take note of this. This is the increase in preference of discharge of ions. But if I come over here, as I go down, is showing increase in preference of discharge of ions. So ions below are preferred over those above. So if I have a case of sodium ion and any of these ions below have more chances to be discharged at the electrode, that's at the cathode, over those above. So when you have this knowledge, now remember, electronegativity is increasing up. Fluorine is more electronegative than OH minus, but OH minus have more tendency to be discharged over fluorine ion. Potassium is more electropositive than gold or silver or hydrogen, but these ones below have more tendency to be preferentially discharged over those above. Now let's look at a good example of electrolysis of acidified water using platinum electrode. Now, what is acidified water? We have H2SO4. Now, this will dissociate in the presence of water. H2SO4 will dissociate in the presence of water. So, what will happen is I will have H, I will have my 2H plus my SO4 2 minus. These are the two possible ions that I can get when this acid dissociates. Now, in the presence of water, I have H plus OH minus. H plus OH minus. Now, mind you, from this compound, I have hydrogen. From this compound, I have hydrogen. So, in my cations, that in my positive ions, they are similar. But in my negative ions, they are not similar. So now I have the anode. Now look at this. I have the anode. I have the cathode. Now my anode is platinum. My cathode is platinum. Now what does this mean? Platinum is one of the electrodes that do not take part in the reaction. Electrodes that don't take part in a reaction, they are called inert electrodes. Just like ions that do not take part in a reaction, they are called spectator ions. So this one does not involve itself in the reaction. Remember we said the three factors that is considered for preferential transfer of ions or preferential discharge of ions, they are one, we said the position of the ions in the electrochemical series. Number two, we said the concentration of the ion. Then number three, we said the nature of the electrode. So this nature of the electrode does not affect this reaction because the electrode is inert. Now let's look. Which of these goes to the anode? The anode, remember, is the positive pole. It will attract the negative ions. The cathode is the negative pole, therefore it will attract the positive ions. So now this will attract the negative ions. Now the question is now, of these two guys, which of them will be preferentially discharged? Now if we come over here to analyze it, I have OH and I have SO4 minus. Now look at this. Remember we said ions below are preferentially discharged over those above. So it means OH minus has the tendency to be discharged over SO42 minus. But please take note, this is a concentrated acid and SO4 is more concentrated than OH minus. Remember, this is water, but this is an acid. Then you now ask, isn't there concentration of ion as one of the factors that determines preferential discharge of ion? Yes, there is, but the distance between these two ions is too far apart. So this ion is more concentrated than this ion. But this ion, in terms of position, is favored to be discharged. It's just like the best athlete in your school and yourself wants to contest for a race and they place both of you on the same starting point, definitely he will beat you on the race or beat you to the race. But if they not take you away and put you just 2 feet or 2 strokes of the feet from where he was, and they say, go, there is still a tendency that he will still beat you to the race. But if they take you farther away from him, close to the finish point, and then I say, go, there is no way he will beat you to the race. So it means, although the guy is more concentrated than you, but the gap of distance will not favor him in the competition. So although SO42 minus is more concentrated than OH minus, but the gap between these two will make this guy not be able to suppress this guy to go. So hence OH minus will be differentially discharged over SO42 minus. So when we come to the anode, this will leave and come to the anode. So this will leave. OH minus will leave and come to the anode. So at the anode, I will have OH minus. So OH minus is preferentially discharged over SO42 minus. So this comes to the anode. Then what now comes to the cathode? Now remember, it's hydrogen, so it will definitely be hydrogen. So hydrogen ion comes to the cathode. Now, each of these ions that comes to the cathode will definitely go off the cathode as a gas. So I'll be having NH plus. Now remember we said always add electrons because this guy will go off to become hydrogen gas. Hydrogen gas. So the question is, this is +1, this is 0. Remember the oxidation number of an atom in a free state or in the state of a molecule is equal to 0. Now look at this now. So what do I do to this place to balance up their charges? I will add plus E minus. Now adding plus E minus now makes this place. This is now 1 plus times minus is minus. So 1 minus 1 equals 0. But to balance it, because this place is now 2, I'll put my 2 here and I will also put my 2 here. So it means hydrogen ion is preferentially discharged at the cathode and is being given up as hydrogen gas. But coming over here, I have OH minus. OH minus would definitely now become 2H2O plus O2 plus 4E minus. Take note of this. Why here I have here to be 4. So this is the balance reaction for 4 for OH minus at the anode, while this is the reaction for H plus at the cathode. Now, what gas is giving up at the anode? We have oxygen gas giving up at the anode, and we have hydrogen gas giving up at the cathode. Now, when this leaves to the cathode, and you have some hydrogen migrating to the anode, what will not be the nature of this electrolyte? The nature of the electrolyte is this will now remain in the solution, making it more acidic. So the nature of the electrolyte will still be acidic because of the presence of SO4 2 minus in the solution. So when we have the electrolysis of acidified water using platinum electrode, what leaves to the anode is the OH migrates to the anode, while H goes to the cathode. The hydrogen ion that goes to the cathode will leave in the form of hydrogen gas, while the OH that goes to the anode will leave in the form of what now? Oxygen gas. Why the nature of the electrolyte that was dissociated will be acidic, why the electrons or the ions that are left in the electrolyte are acidic ions. Thank you. Now let's look at example 2, electrolysis of copper 2 tetraoxosulphate 6 using copper cathode and carbon or platinum as anode. So now we have CuSO4, then we have it as aqueous, then we have in the presence of water. Now remember, all of these electrolytes will dissociate in the presence of water. So we have this will give us Cu2 plus SO4 2 minus, and we have this to give us H plus OH minus. Now remember that these are our positive ions, while these are our negative ions. These are positive ions and these are our negative ions. Now the question is, of these two, which one will be preferentially discharged? Of these two, which will be preferentially discharged? Now remember, let's take it like this. We have the anode. What is our anode? Our anode is carbon or platinum. Any of the two, we obey the same principle because both of them are inert. They do not take part in the reaction. But in our cathode, we have copper in our cathode. We have copper in our cathode. Now, let's look at how it goes. Now, remember, what is the cathode? The anode is the positive, while the cathode is the negative. So, we are saying that negative ions will go towards the anode. So, which are our negative ion? I have SO4, 2 minus and OH minus. Now come back to our electronegative series. Now for exam purpose, where you have to produce this yourself, you can make use of this acronym. Francis shows no conscience, beating Irene often. I reiterate again, Francis shows no conscience, beating Irene often. But for this, you want to learn how to write it without you going through your textbook, is to say, please, please, please. The please is for potassium. Please starts with P, please. So the P here is for potassium. So please, Sa. The Sa here it starts with X. X is for sodium. Call. Call, C-A-double-L. Call here is calcium. C stands for calcium. Call me, magnesium. M for me, magnesium. Allergy, allergy, allergy. A for aluminium. Zanko, Z for zinc. He, sorry, Zanko, in. I for iron. D, let me just spell, please, sir, call me, allergy, Zanko, in the lab, he can make some gold. So P is for potassium, X is for sodium, C is for calcium, M is for magnesium, A is for aluminium, Z is for zinc, I is for iron, T is for tin, L is for lead, H is for hydrogen, C is for copper, M is for mercury, X is for silver, and G is for gold. So you have all of these here. Now back to business. Now the question is, I have SO4 2 minus and OH minus. Remember we said that this one is being favored in terms of position. Ions below are preferentially discharged over those above. Although this one is more concentrated, but the gap is too much. We'll see a question where this guy is supposed to be favored, but concentration will limit this guy from going and favor the one of concentration. But because the gap is too much, the gap between these two ions are much, so hence concentration will have no effect to pull down this ion from leaving. So position will favor this ion to leave. So where will this ion go to? These are negative ion, they will go to the positive electrode, so they will come to the anode. So which one is going now? OH minus is going. So I will have OH minus is preferentially discharged to the anode. Now I have copper and hydrogen. Now, ordinarily, if you check the series, hydrogen and copper, which of them is preferential? Which of them does position favor? Position favors copper because copper is below hydrogen. If you check concentration, which one does concentration favors? Concentration, copper is to aqueous. Copper is to aqueous. So copper is more concentrated than hydrogen. But you still see it again. Copper, which is more favored in terms of concentration than hydrogen, is also more favored than hydrogen in terms of position. Hence, instead of hydrogen to go, copper will not go. So copper is preferentially discharged over hydrogen. So what do I have here? I have Cu2 plus. So these ions are the ions that migrated, leaving H and SO4 2 minus in the solution. So this and this opt out and migrated towards the electrodes, while this and this are left in the solution. So it means this solution will not be acidic. Yes, because I have acidic ion present in the water in the solution. And also remember, ordinarily copper 2 tetraoxosulphate 6 ought to be a blue solution. It has a blue color, but because copper will migrate out of the solution towards the electrode, the blue color will not be fading gradually. Why is the fading occurring? Is because the copper, which introduces the blue coloration, is now migrating towards the what now? towards the cathode. Now, when copper comes to the cathode, what will happen? We said it will be deposited as copper deposit. Copper ion will be deposited as copper deposit. So remember, this is plus 2. Why this is 0? What has happened? Reduction has happened. So what do? We put plus 2e minus. So this is a reduction reaction that occurs in the cathode. This is the half cell reaction that occurs in the cathode. What about in the anode? OH minus. Remember, I've told you OH minus will now further become H2O plus O2 plus 4E minus. Take note of this reaction, is very important. Why here becomes 4. Now, what has happened here? Look at this. Oxygen is minus 4 becoming 0. So you notice that what has happened here is actually oxidation reaction. What has happened here is actually reduction reaction. Now the question is, what will happen to the size of this copper? Will the size of the copper increase or decrease? Take note, the size of the copper will increase because more copper ions came towards the copper electrode. What will happen to the solution? Remember, we said the blue color of the copper 2 tetraoxosulphate will be fading gradually. Why is it fading? Because copper from the solution migrated towards the electrode, which is the cathode of the circuit. Thank you. Now let's look at another example, which is now example 3. Electrolysis of molten sodium chloride. Molten. This is a very important word that you have to take note of. Molten sodium chloride. Sodium chloride on its own is a typical ionic compound and it's in a solid form. Sodium chloride is a typical ionic compound and in a solid form where you have the sodium and the chlorine. Now remember that this is a compound. This is sodium chloride, and the sodium and the chlorine in normal sodium chloride, which is a typical ionic compound, they are not mobile. They are not mobile. But in a molten sodium chloride, the sodium and chlorine are mobile. So a molten sodium chloride will give us Na plus Cl minus. Take note, it is not an aqueous sodium chloride. It is different if it was aqueous sodium chloride. If it's an aqueous sodium chloride, it means there is a presence of water. And so it will not be including H2O. So that give us H and OH minus. But for molten state, it has just 2 ions present, which are ions from the compound. So take note of this. Another example is aluminium oxide. Aluminium oxide. Molten aluminium oxide. We will just dissociate to give you aluminium and oxygen. Oxygen ion. That's how it works. So when it is in a molten form, you don't include water. You just have the 2 ions that are present in the compound. So now if these are the ions, remember we have the anode and we have the cathode. We have the anode, we have the cathode. This is the positive, while this is the negative. Now remember, sodium ion, which is the positive ion, will migrate towards the negative pole, while chlorine will migrate towards the positive pole. Now remember, these 2 electrodes are carbon-carbon or graphite-graphite electrode. So what will come here is our Cl minus will come here, and what will come here is our Na plus that will come here. Now remember, this will be deposited as chlorine gas. This will be deposited as chlorine gas, while this will further give us sodium. Now remember to balance this up. This is plus 1, this is 0. Always add electrons to the side with a higher charge. So this is plus 1, this is 0, so plus E minus. Plus E minus. While here, I will either do it in this format. Now, add electrons to the side with a higher charge, but in this case, subtract electrons from the side with a lesser charge. So this is giving us as now this is -1, this is 0. So -1 has a lesser charge. So subtract electrons from the side with a lesser charge. So this will either be Cl minus. Now to balance this is already 2. I will put my 2 here, minus 2E minus to give us Cl2. This is one way I can do it. Another way I can do it is I will now take this -2 this way. Take -2 this way, it becomes +2. So it becomes 2Cl minus to give us Cl2 plus 2E minus. So this is the anodic half-cell reaction, while this is the cathodic half-cell reaction. So this is how it will look like in a molten sodium chloride. Now, if you check this out, what do you have? I have chlorine gas released at the anode, and I have sodium deposit at the cathode. This is for electrolysis of molten sodium chloride using carbon-carbon or graphite-graphite electrode. Now let's look at example 4. This time we are now having electrolysis of aqueous sodium chloride. Aqueous sodium chloride. Now remember, aqueous sodium chloride shows that there is a presence of water, but molten shows that the only mobile electrons you have, the mobile ions you have, is sodium and chlorine. But a typical sodium chloride crystal is a solid, and the electrons are not mobile. So now I will have sodium chloride in the presence of H2O. So this will dissociate to give us Na plus Cl minus, while this will dissociate to give us H plus OH minus. Now the question is, now I have anode and I have the cathode also. I have the cathode. Now both of them are carbon-carbon. This is positive, while this is negative. Now these are my two cations and these are my two anions. Cations are positive ions, anions are negative ions. Now the question is, of these two, which one will be discharged preferentially? Of these two, which will be discharged preferentially? Now you know that this is already at the top, while this is at the bottom if you compare with our tables. So you see that hydrogen will be more discharged or preferentially discharged over sodium at the top. Although sodium is more concentrated, but the gap is too much, so it will have no effect on hydrogen. Hence, hydrogen will be preferentially discharged over sodium. So it means this will go where? To the negative electrode. So I have H plus and negative electrode. Now of these two, which of them will go? Now come back to this place. I have OH minus and I have Cl minus. OH minus and Cl minus. Which of these two is position favoring? OH minus, because ions below are preferentially discharged over those above. But which of them has a higher concentration? Chlorine has a higher concentration because this is the aqueous solution. This is the aqueous solution. So chlorine is more concentrated compared to OH. OH is coming from water. Chlorine ion is coming from sodium chloride, and so this is concentrated. Hence, this ion is more concentrated than this ion. But this ion is being favored by position rather than this. But the question is now, concentration has more effect than position. If the position is close, the one that ought to be favored, if the positions are not that too far, the one that is more favored by concentration will have edge over the one that is being favored by position. So if you look here, the distance between chlorine ion, the chloride ion, and the OH ion is not that far apart. So it brings me back to you running, or you wanting to contest the best 100-meter athlete in the world, and they put him behind, and just a little stroke and they put him ahead, and they put you ahead of him. Now they're not saying that both of you should run. Despite the little gap, he will still outrun you in the competition because the position is not enough to neutralize him from winning the race. So it means that chlorine will be more favored, although OH has the chance based on position, but based on concentration, this will be more favored over this. So now at the anode, chlorine, the chloride ion will go. So I now have my Cl minus at the anode. So now let's now see. This will be given up as hydrogen gas, while this will be given up as Cl gas. That is what we'll be having in this equation. Now, what will I do to balance up the reaction? This is 2 here, I will put my 2 here. This is 2 here, I'll put my 2 here. Now, this has more ion because this is now plus 2, this is 0. So I'll put plus 2e minus here. Always add electrons to the side with a higher charge. This side has a higher charge. I'm adding electron to neutralize the charge to equal 0. What about this place? I will subtract electrons from the side with a lesser charge to make it equal 0 also. So now this is now minus 2e minus. So this is now 2 minus 2 minus minus 2. So it now become minus 2 plus 2, which is the same thing as 0 here. So another way I can write this reaction is take this minus 2 this way, it becomes 2Cl minus to give us Cl2 plus 2e minus. This is now what we call the anodic half cell reaction. That's what we call this. Why this one is now called the cathodic half cell reaction. Half cell reaction. Now, what are the products left? What will now be the nature of our electrolyte? Remember, this one left and this one also left, leaving sodium and OH minus, meaning the electrolyte will be alkalinic. The electrolyte will not be alkalinic. Then what about this? Now take note. These are important questions. What are the product formed during electrolysis of brine? The product form are 1. Sodium hydroxide, number 2. Chlorine gas, number 3. Hydrogen gas. All these are product formed during electrolysis of brine. These are the 3 product formed during electrolysis of brine. Now the question is, why is the anode always carbon? In this electrolysis, the anode is always carbon. Why? Because chlorine giving off at the anode do not attack carbon. Chlorine gas do not react with carbon. Hence, it's always carbon or graphite so that it will allow a free flow of the chlorine gas. Now remember again, I said the 3 product form are sodium hydroxide, you can see that from here. Chlorine gas, you can see that from the anode, and hydrogen from the cathode. Now let's see Faraday's laws of electrolysis. What does Faraday's laws of electrolysis state? The first law states that the mass of the substance deposited during electrolysis is directly proportional to the quantity of electricity that passes through it. So that means that mass is proportional to quantity of electricity. Now remember, quantity of electricity equals current times time. So therefore, we can say mass is proportional to IT, current times time. If you remove the proportionality sign, you bring in a constant. We now have mass is equal to, we have electrochemical equivalent, which is your Z, IT. So what is Z? Z is electrochemical equivalent and is equal to mass over IT, which can also be Z, is equal to mass over Q. So these are formulas that can help us know that this is how the law is being explained mathematically. So remember, Z is called electrochemical equivalent. Electrochemical equivalent, the mass deposited when one current passes through per unit time. So that is our electrochemical equivalent. But mind you, how is this explained based on preferential discharge of ions? Because it's preferential discharge of ions that aids us or assists us to calculate for Faraday's first law. Now, for instance, this could be a cathodic reaction. Remember, these are positive ions and they go to the negative electrodes. So this kind of a ion will definitely migrate to the cathode if need be. Now we have sodium ion plus 1 electrons to give us sodium deposit. Now remember, this can be analyzed as 1 electron or 1 Faraday or 96500 coulombs. Now take note, I can either use 1 electron or 1 farad or 96500 coulombs of electricity. So we are saying that any of these are equivalent depending on which of the question, which of them is allowed in my question. So this equation is showing me that 1 electron, or 1 Faraday or 96500 coulombs of electricity is needed to deposit 1 mole of sodium atom or 23 grams of sodium. Now, my question is going to take any of this shape, but I'm telling you what this equation means. This is the analysis of this equation. And what is it? That 1 electron or 1 Faraday or 96,500 coulombs of electricity is required to deposit 1 mole of sodium atom or 23 grams of sodium. So they will not ask you how many Faraday is needed to deposit. For instance, 2.3 grams of sodium. So you will not say, if 1 Faraday gave me these grams of sodium as standard, therefore X Faraday will give me 2.3 grams of sodium. That's how it is solved. Very simple. We'll solve some questions. Now, what about if it's something like this? How do I analyze this equation? I will say 2 electrons or 2 Faraday or 2 bracket 96500 coulombs of electricity is required to deposit 1 mole of copper or 63.5 grams of copper. This is how I will analyze it. So any other one that is not going to be asked me, I will not substitute that in and find it as X. Now, what about this? How can I explain this? Because we'll be seeing all of this as we go further in the question. Now, how could I explain this? This can be explained by saying 2 electrons or 2 Faraday or 2 bracket 96,500 coulombs of electricity is required to deposit. Now remember, this can be in grams or a gas. Is required to deposit 2 grams of hydrogen gas or 22.4 dm cube of hydrogen gas. So this could come as a gas or as a mass because hydrogen is a gas. Now, what about this? This could be explained as that 2 electrons, look at it here, 2 electrons or 2 Faraday or 2 bracket 96500 coulombs, all of these are the same thing, is required to deposit. What is it required to deposit? It's required to deposit 71 grams of chlorine gas. This is 71 grams because it's 35.5 times 2. That's how I got my 71 grams or 22.4 dm cube of hydrogen gas. Remember, this is the standard volume of a gas. Now, what about this for oxygen? Take note of oxygen. Oxygen will now be, this is oxygen, and this is the number of electrons. So it will be 4 electrons, or 4 Faraday, or 4 bracket 96500 coulombs of electricity is required to deposit. Oxygen is 16 times 2, 32, which is now 32 grams of oxygen, or 22.4 dm cube of oxygen gas. So once the question is given and you can know the reaction for the discharge of the ion, you can just hit it once and know how to solve the required question. Now let's look at example number 1. It says calculate the mass of silver deposited when a current of 2.6 ampere is passed through a solution of silver salt for 70 minutes. Now remember, if I want to solve this question, silver, I will say Ag plus is depositing Ag. To balance this up, I will say plus E minus. So I've balanced the reaction. Now what does this one mean? It means that, just like what I explained, it means that 1 electron, or 1 Faraday, or 96500 coulomb of electricity we deposit silver here is 108, will give us 108 grams of silver. That's what this equation at the anode have shown us, sorry, at the cathode has shown us, because a positive ion will go to the cathode. Now the question now says calculate the mass of silver deposited when a current of 2 ampere passed for 70 minutes. So it means, what is now the quantity of electricity? Quantity of electricity will be equal to IT, which is equals, what's the current? 2.6 times, what's the time? 70 minutes, which will now be 70 times 60, 10,920 coulombs. That's what this will give to us. So now, recall, of these three, I'm using coulombs to solve. Why? Because the question provided for me coulombs of electricity. So I will now say, therefore, 96500 coulombs of electricity gave us 108 grams of silver. Therefore, what about this one now? 10,920 coulombs will now give me X. What is my X? X will now be equal to 10,920 times 108 over 96500. That's, if you cross multiply this, this will times this, divide by this. So my X will now be equal to 12.22 grams. That becomes the answer to this question. Now, this question can also be solved. Some people call it a shortcut formula, but actually, I will show it to you that is actually here the formula is being derived from. Now, watch this. Remember, we said that 1 electron, or 1 farad, gave 108 grams of silver. So we are using 1 farad here. So it means if we're using 1 electron here, it would have been 1 electron give me this. But because I'm using farad, I'm now having 96500 coulombs to give this. Then when I said this, which is the quantity of electricity, give X. So X is now equal to everything here. So I can say that X is equal to, this guy came as a result of quantity of electricity, which is IT. So I can take everything here as my Q times everything here as my molar mass over everything here is my farad. Now, but there is something I will always add to farad or Faraday. What is that thing? I will add number of electrons, because if this ion is plus 2, I would have said 2 times 96500 coulombs. If this ion was plus 3, I would have said 3 times 9655 coulombs. Now, because it is just 1, that's why I'm doing 96550 coulombs of electricity. So there's always going to be an effect of the number of electrons here. So it will not be F times E, not just F. Now this is what some people call shortcut formula. So it will not be X is equal to Q equals IT times molar mass over Faraday times the number of electrons. So for this place, it will still be 96,500 times 1. So this formula can also be used to solve it. Actually, is this same thing that resulted in this formula. So it's not actually a shortcut formula. It's just an abbreviation of what was solved. Now let's look at question number 2. It said during the electrolysis of dilute tetraoxosulphate 6 acid solution, 0.5 mole of electrons were passed. What volume of the gas was produced at the anode? Now we have H2SO4. It will occur in the presence of water. And so this will be 2H plus SO4, 2 minus, in the presence of H plus OH minus. Now remember, you have at the anode and you have at the cathode. Remember, the cathode is negative, the anode is positive. So the anode is where we are considering at the anode. Now at the anode, which ions will come over this way? It's either of these two. Now remember, based on position, this will be favored, OH minus. So my reaction is OH minus to give me H2O plus O2 plus 4 electrons. So this is 4 and this is 2. So this is the equation for what we go to the anode. So OH minus ion will go to release oxygen gas. So now this is the reaction at the anode. It's called the half-cell anodic reaction. So now what about this? What we have here now is 4 electrons or 4 Faraday or 4 bracket. You see now we are using 4 to times Faraday because of the number of electrons we have. 4 times 96500 coulombs of electricity we give now, remember, standard volume will give 22.4 dm³ of oxygen gas. So this is the standard based on the equation for electrons. Now the question is being asked in moles of electrons. So therefore, I will be using this side. I will not be solving with 96500. Why? Because my question is being asked as in the form of electrons. So now this against volume. So what do I have? So I have 4 electrons gave 22.4 dm³ of oxygen gas. Therefore, this is 4 moles of electrons. So therefore, 0.05 mole will give X. What is now our X? Our X is now 0.05 times 22.4 over 4. So what becomes our answer is now equal to 0.28 dm³ of oxygen. Now let's see another example. What volume of chlorine at STP is produced when a current of 20 ampere is passed through molten sodium chloride. Now remember, I said molten sodium chloride is NaCl. If you dissociate, it will just be Na plus Cl minus. There is no water present. So the anode, this will be the gas to go to the anode. So that's why the question is asking what volume of chlorine gas. What about if the question was what volume of oxygen gas will be liberated at the anode? Now, the answer will be zero. Why? Because there is no probability, there is no assurance that oxygen gas will be at the anode. Why? Because in a molten sodium chloride, the only ions present will be sodium and chlorine ion. So this will now go to the anode as Cl minus to give us chlorine gas. Balance this up, this will be 2, then we'll put plus 2 in minus. We said, or it can also be 2Cl minus. Bring this one here, it will be minus 2E minus to give us Cl2. So now this means that 2 electrons or 2 Faraday or 2 bracket 96500 coulombs we give us. Now we are not solving the mass of chlorine, we are solving the volume of chlorine gas. So it will be 22.4 dm3. So therefore now the question is now this current, which is my I, and for 2 hours, remember Q equals IT, which is now equals 20 times 2 hours will be 2 times 60 times 60. So this will be equal to 144,000 coulombs. So now I already know what this coulomb will produce. 2 times 96500 coulombs will give me 22.4 dm3. So now what will this one now give to me? So I will now say 2 bracket 96500 coulombs will give me 22.4 dm3 of chlorine gas. Therefore, now 144,000 coulombs will give me X. Now, what is my X? My X will now be equal to 144,000 times 22.4 over 2 times 96500. So my X will now be 16.71 dm cube of chlorine gas. So you see, it's very simple. It's just for you to understand how preferential discharge of ion helps us to calculate everything down. Thank you. Now let's see another example. Example 4. What mass of aluminium will be produced in 1 hour by the electrolysis of molten magnesium chloride by 10 ampere? Now molten again, so there will be no presence of water. So it will be AlCl3, that will become Al3 plus Cl minus. Now chlorine is 3 here, so I'll put 3 here. Now this 3 does not affect this one here. This is the ion, but this is the number of atoms. That's why I'm balancing it up with a 3 here. Now the question is now, this will go to the cathode, will go to the negative and negative electrode, which is the cathode, while this will go to the anode, which is the positive electrode, which is the anode. But now the question is asking us what mass of aluminium will be produced. So we are focusing on aluminium this time, not on chlorine. So what is the half cell cathodic reaction? It will be Al3 plus to give us a deposit of aluminium solid. So now to balance this up, I will add plus 3E minus here. Always add electrons to the side with a higher charge. Here is plus 3, here is 0. So I have to add plus 3 to make this place equal to 0. So that's why I'm putting it here. Remember, it can also be written as take this plus 3 to this side, it becomes minus 3. It can also be Al3 plus to give us Al minus 3E minus. This equation and this equation are the same. Now, when you have this, what does this mean? We said it means that 3 electrons or 3 Faraday or 3 times 96500 coulombs of electricity would deposit 27 grams of aluminium. That's what this equation explains to us. Now, so I'm not being asked, this is the current and this is the time. So remember Q equals IT. So Q equals as quantity of electricity equals I is 10 times what is 1 hour? 1 times 60 times 60. So 6 times 6 is 36. 1, 2, 3. 3 zeros. 1, 2, 3. That's 36,000 coulombs. So now I am working with coulombs, so I will still work with coulombs here. So I will say 3 times 96500 coulombs gave me 27 grams of aluminium. Therefore, 36,000 coulombs is going to give me 36,000 coulombs is going to give me X. What is my X? My X is now 36,000 times 27 over 3 times 96500. So if you do that, our final answer will be 3.36 grams of aluminium. Now let's look at Faraday's second law of electrolysis. It states if the same quantity, now take note of this word, very important in this second law, if the same quantity of electricity is passed through different electrolytes, the relative number of moles of the element discharged is inversely proportional to the charge of the ion. Now look at this, very important. I have, for instance, I have mathematically mole is inversely proportional to charge. Very important. So I have mole is inversely proportional. Let's take charge as C. So I have mole is equal to K over C. Cross multiply, I have mole times charge is equal to K, which is a constant. Now it means I have mole 1, charge 1 is equal to mole 2, charge 2. This is important to note. Now recall mole equals mass over molar mass. Mole equals mass over molar mass. Take note of this. So therefore, I cannot have it as mass over molar mass of 1 times charge of 1 is equals mass over molar mass of 2 times charge of 2. So this can be broken down to this place. It can still be just like this. Now it means that if we have two different electrolytes, we can solve for any of these variables under Faraday's second law. Now we'll be looking at some examples for Faraday's second law. Now we'll be looking at an example of Faraday's second law. What mass of silver would be liberated from a solution, watch it, you see the word, by the same quantity of electricity? Remember our law states if the same quantity of electricity. So now it means this is a typical Faraday's second law. What mass of silver would be liberated from a solution by the same quantity of electricity that liberates 0.32 grams of copper? Now remember, I'm dealing with silver and with copper. Now, what is the half cell reaction of silver? It is Ag plus E minus to deposit Ag. What about for copper? It is Cu, it is Cu2 plus 2E minus to give you Cu. So this is the solid, this is the solid. Now remember, what is the expression? How is this expressed? We can say, if I was solving Faraday's first law now, I will start doing 1 electron or 1 Faraday or 96500 will give me 108 grams of silver. That is not the procedure that we have here. Now remember, what does the law state? It states that the mole of the element deposited is inversely proportional to the charge. Now, this is the charge of the element. This is the charge of the ions. So the charge of the charge of the ion, which can also be the charge that I need to take this position. Now remember, my question is not giving me in moles, but is giving me in grams. That is in mass. So I will not be using this. Rather, I'll be using this because I need to get my answer solved in mass. It's still simple. I can solve it out in moles, then I cannot convert from moles to mass. That's very important. So now, what do I have now? So I have from here, I have N1, look at it, N1 C1 is equals N2 C2. Now, what is my N1? In my question, silver is appearing first, so I'll say N silver times charge of silver is equals mole of copper times charge of copper. So this will be a very nice way to replace my 1 and my 2 for copper. Now, what is now the way to solve it? What is my mole of silver? I do not know my mole of silver. I'm looking for the mass of silver. So I can say the mole of silver, which is unknown, times what is the mass of silver? Sorry, what is the charge of silver? Is 1 times 1 is equal to what is the mole of copper? The mole of copper was not giving me, it was the mass of copper that was giving me. But remember, I can solve for mole by using mass over molar mass. So now I will replace this place with mass over molar mass. So what is the mass of copper? It is 0.32 over, what's the molar mass of copper? It's actually 63.5. So times 63 point, sorry, divide by 3.5 times, what is the charge of copper? The charge of copper is 2. So you see, I have successfully worked this place out in this particular place. Remember, the mass, the mole of silver, I don't know, I left it that way. The charge of silver is 1, that's it here, is equal to the mole of copper, I don't know, but I know the mass of copper. The mass of copper is 0.32. Then divide by the molar mass, because mole equals mass over molar mass. Then times the charge of copper, which is 2 plus, which is 2 here. So now what becomes the answer to this question? The answer to this question is now mole of silver times 1 is the same thing, is equal to 0.01. 0.01. So now, what is now the question? Since I have gotten the mole of silver to be 0.01, can I find the mass of silver? Yes, I can find the mass of silver. Remember that mole equals mass over molar mass. Mole equals mass over molar mass. So I would not say if mole equals mass over molar mass. So what would not be mass? Mass is now equals mole times molar mass, which equals, what's my mole? 0.01 times, what's my molar mass? 108. The molar mass of silver is 108. So what will be this? 1212. The answer is now 1.08 grams. That becomes the answer, 1.08 grams. So the answer to this question is 1.08 grams. How did I solve it? I reiterate, this helped me to know the charge of silver and the charge of copper, because the question is regarding or is relating to copper and silver. So I apply the formula that I have because I know that the mole is inversely proportional to the charge. So from there we arrive here and we use the quantities or the factors that were given us to solve, and we arrived at 1.08 grams. Thank you. Now let's look at another critical example for Faraday's second law. It says a current is passed through, this time three electrolytic cells connected in series. Now remember, if they are connected in series, it will be the same quantity of electricity that will pass through them. So that is another ideology to know that it is talking about Faraday's second law. So connected in series containing solutions of, now look at the solutions. We have the solutions. The first one is AgNO3. That's it. Then we have the second one. Another solution is, let me take them in this manner. Another solution is CuSO4. Then we have another one again, which is the last one, NaCl. So these are the solutions we have respectively. Now, if 2.17 grams of copper is deposited in the second cell, that's what this is the second cell, calculate the mass of silver deposited in the first cell and the mass of chlorine deposited. Now remember, this is not a molten sodium chloride, it's a solution of sodium chloride. Now let me refresh your memory about which of these, although the question already told us that we are looking for silver here, why here we're looking for copper, why here we're looking for chlorine. Now remember that there is something I just taught previously about preferential discharge of ion. So I will not want to go through that same process again. So let me just pick out the element that the question is asking us to calculate for. So now what do we have here for silver is Ag plus E minus to give us Ag. Remember, this is how silver is expressed. Why for copper, it will be Cu2 plus 2E minus to give us Cu. Why for chlorine, it will be Cl minus, then it will deposit for us Cl2. We come here and put 2, then we put plus 2E minus here. So these are the half cell reaction of each of the elements that we'll be looking out for here. Now remember that we said Faraday's second law, the mole is inversely proportional to the charge. The mole is inversely proportional to the charge. That will now lead us to N1C1 equals N2C2. Now remember this formula. So now if you ask yourself, what is the first one that we were asked here? We said if 12.17 grams of copper is deposited in the second cell, calculate the mass of silver deposited. So now I'm comparing this and this, the second cell to the first cell. So I will say that now this is now mass of mole of silver times charge of silver is equals mole of copper times charge of copper. So I'm solving with this. Now my question says I should calculate the mass of silver. So my question is the mass of silver. So now remember, I will not be able to find the mass of silver unless I know the mole of silver. So let me first of all look for what is the mole of silver. The mole of silver will not be the mole of copper times the charge of copper over, you now have the charge of silver. So it means the mole of silver is equal to, what is the mole of copper? The mole of copper is mass over molar mass. Do I have the mass? Yes, I have the mass. The mass is giving me as 12.17. So it will be 12.17 over what is the molar mass of copper over 63.5? This is everything here times, what about the charge of copper? The charge of copper is 2 times 2. Now remember, it will not be everything. Now let me do it this way. Then let me take it this way. mole of this is equals, then divided by what is the charge of silver? The charge of silver is 1. You have the charge of silver as 1. So what would that be the answer to the mole of silver? The mole of silver will not be equal to 0.38 mole. The mole of silver is equal to 0.38 mole. Now, if I have the mole of silver, can I find the mass of silver? Yes. How will I find the mass of silver? Mole is equals mass over molar mass. So what is the mole? The mass is not equals mole times molar mass. What is the mass of silver? The mass of silver is not the mole of silver, which is 0.38 times, what's the mass of silver? The molar mass of silver is 108. The molar mass of silver is 108. So what becomes the answer? The mass of silver will now be equal to 41.04. 41.04 grams. That becomes the mass of silver. 41.04 grams becomes the mass of silver. Now, what's the next question? The next question, which is our question number 2, says that we should calculate the volume of chlorine gas liberated in the third cell. The volume of chlorine gas liberated in the third cell. Now, question, how can I solve for that? Now, I will still make use of, I will compare this now to this. So, I'll be making use of the N1C1 is equal to N2. Sorry, now this is not my 2, N2C2. Now, what is the mole here? The mole of copper, we have solved for that before. Remember, everything about this is for copper. Everything about this is for copper. So let me just do everything again. Now we're looking for the volume of chlorine gas liberated in the third cell. So now it will now become, let's solve for the mole. Mole of copper will now be mass over molar mass times charge. Everything here is of copper is equals mole times charge. Everything is for chlorine gas. Now, what do I have here? I have, what's the mass of copper? The mass of copper in the question is, that's 12.17 over 63.5, then times the charge of copper is 2. Everything is equal to, what is the mole? The mole of chlorine, I do not know, times, what about the charge of chlorine? Remember, it's 2. That's the charge of chlorine. It's 2. How is it 2? 2 times minus 1 is 2. So, because of that, it becomes 2. So now, what do we have here? This already will give us 0.38. So, everything here is equal to 0.38 is equal to 2n. So my n is now equals 0.38 divided by 2. So my n is now equal to 0.1, then 0.19 mole. Now, if this is mole, now what am I looking for? I'm looking for volume. That's what the question asks us to calculate for volume. Now we have gotten the mole of chlorine gas is equal 0.19 mole. Now, if you remember, we have mole is equal to volume of gas over 22.4 dm cube. That's one of the formulas we gave for mole. You can watch our mole video to know more about these formulas. Now, what is now the volume of chlorine? Volume of chlorine gas will now be equal to mole times 22.4. So it will now be equal to, what's our mole? 0.19 times 22.4. What is now the answer? Now, what becomes the answer is now equal to 4.256 dm cube of chlorine gas. Now, how did I solve this? Remember, I had 3 different cells and I was giving information concerning copper. but because I know how to correlate, I have to now do this against this to solve for silver. Then I did this against this to solve for chlorine. So on solving, I found the mole of chlorine. Then from mole, I now looked for the volume of the gas of chlorine that was asked me in the question. So this is how this is solved for such involving three cells. Thank you.